Today, we will discuss about the derivatives of trigonometric functions. For the outline, D10, the derivative of sine, D11, the derivative of cosine, D12, the derivative of tangent, D13, the derivative of cotangent, D14, the derivative of secant, and D15, the derivative of cosecant. The derivative of sine u is equivalent to cosine u times du over dx. For our example, we have sine 2x. For the first part, we will get the derivative of 2x, which is 2, then cosine 2x. So the answer is 2 cosine 2x. Y equals to 1/2 x minus 1/4 sine 2x. So for u, we have 1/2 x. For du, we have 1/2. For v, we have 1/4 sine 2x. And for dv, we have 1/2 cosine 2x. So y prime is equals to 1/2 minus 1/4 times 2 cosine 2x equals to 1/2 minus 1/2 cosine 2x. Next is 1 minus cosine 2x over 2. Next, we have 1 minus cosine squared x minus sine squared x over 2. Next, we have 1 minus cosine squared x plus sine squared x over 2. Next, we'll have sine squared x plus sine squared x over 2. Next, we'll have 2 sine squared x over 2, cancel 2, and we'll have sine squared x as the final answer.
D11. Cosine u is equals to negative sine u d over dx. For example, two cosine 2x is equals to 2 times 2 negative 4 sine 2x. For example, y is equals to sine x over 2 plus cosine x. Here we will use the derivative 6, which is equal to v du minus u dv over v squared. U is equals to sine x, du is equal to cosine x. V is equals to 2 plus cosine x, dv is equal to negative sine x. Next is we get the y prime, which is 2 plus cosine x, then get the du, which is cosine x minus sine x and negative sine x over with the v squared, which is 2 plus cosine x squared. Then we multiply the derivatives 2 plus cosine x and cosine x, which will become 2 cosine x plus cosine squared x. The next one is sine x, and negative sine x is equal to negative sine squared x over 2 plus cosine x squared. Next is you have to add the following. You have to remember that cosine squared x plus sine squared x is equal to 1. So the answer is 2 cosine x plus 1 over 2 plus cosine x squared. Then rearrange it, 1 plus 2 cosine x over 2 plus cosine x squared.
D12. The derivative of tangent u is equivalent to secant squared u multiplied by the derivative of u. For example, we have 6 tangent 3x. The derivative of 3x is 3 multiplied by 6 secant squared 3x. 6 times 3 is 18, so we will get 18 secant squared 3x. For another example, we have tan x, tan 2x. Since we have tan x, tan 2x, we will apply the d4, which will find the u, the derivative of u, the v, and the derivative of v. For u, we have tan x. The derivative of u is equal to secant squared x. V, we have tan 2x. The derivative of v is equal to 2 secant squared 2x. For d4, we will apply the u multiply derivative of v plus v multiplied by the derivative of u. So we have tan x multiplied by the derivative of v, which is 2 secant squared 2x, plus v, which is tan 2x multiplied by the derivative of u, which is secant squared x. Then we will have 2 tan x secant squared 2x plus tan 2x secant squared x.
For D13, the derivative of cotangent u is equal to negative cosecant squared u times the derivative of u with respect to x. For example, given y is equal to 4 times cotangent 3 minus 2x. To find out the derivative, we have 4 times negative cosecant squared times 3 minus 2x times the derivative of 3 minus 2x, which is equal to negative 2. Whoops, negative. So, cancel the negative signs. We have 8 cosecant squared times 3 minus 2x. For another example, y is equal to x plus cotangent x. First, in this equation, we need to find out the u and the v, the derivative of u and the derivative of v. U is equal to x, and the derivative of u, which is the derivative of x, is equal to 1. V is equal to cotangent x, and the derivative of v is equal to negative cosecant squared x. So we just add du and dv, which will be equal to 1 minus cosecant squared x. And that's it.
D14 d over dx. Secant u is equivalent to secant u tan u du over dx. For example, secant 2x is equal to 2 secant 2x tan 2x multiplied to 2. Next is 2 times 2 is equals to 4. 4 secant 2x tan 2x. For another example, y is equal to secant x over sine x. Here we will use the d6, which is v du minus u dv over v squared. U is equal to secant x, derivative of u is equal to secant x tan x. V is equal to sine x, and dv is equal to cosine x. The derivative of y is equal to sine x multiplied to secant x tan x minus u dv, which is secant x multiplied to cos x over v squared, which is sine x squared. Then you have to multiply the following factors: sine x and sec x tan x. The answer is sine x tan x minus the product of sec x and cos x, which is sec x cos x over sin x squared. Next is you have to get the fundamental identities of the following: sin x over 1 over cosine x, and tan x is equals to sin x over cosine x, minus the fundamental identity of secant x, which is 1 over cosine x over cosine x, sin x and cosine x is equals to tan x. Then the answer is tan squared x minus 1, because cosine x over cosine x is equals to 1. Last, tan squared x minus 1 over sin x squared. That's the final answer.
D15. The derivative of cosecant u is equivalent to negative cosecant u cotangent u multiplied by the derivative of u. For example, we have 5 cosecant 3x. The derivative of 3x is 3. So, multiply to negative 5 cosecant 3x cotangent 3x. 3 times negative 5 is 15. So, we will have negative 15 cosecant 3x cotangent 3x. So, we should apply the identities to make it more simple. Negative 15 cosine 3x over sine squared 3x. We will have that final answer. For another example, we have 2 sine x cosine 2x. Since this is 2 sine x cosine 2x cosecant 2x, we will apply the d4. U is equal to 2 sine x. The derivative of u is equal to 2 cosine x. Well, the v is cosecant 2x, and its derivative will be negative 2 cosecant 2x cotangent 2x. The formula will be u multiplied by the derivative of v plus v multiplied by the derivative of u. So, substitute. We will have 2 sine x multiplied by the derivative of v, which is negative 2 cosecant 2x cotangent 2x, plus v, which is cosecant 2x multiplied by the derivative of u, which is 2 cosine x. Then solve. We will have 4 sine x, negative 4 sine x cosecant 2x cotangent 2x, plus 2 cosine x cosecant 2x. And that will be the final answer.